All right, so we'll go ahead and get started with lesson 24. All right, so we're going to revisit functions. All right, we have seen functions before, but it's been a while. Anybody remember where we saw functions? All right, no, stretching. Okay. All right, if you think back to our good friend Carol the dog, all right, our first function we learned about was weeks ago, and we taught a little dog to turn right by turning left 3 times. Okay, y'all remember doing that? Okay, so the same thing applies in a game lab as it did in the little Carol world. It's the same programming language. Okay, it's JavaScript. So you create a function, all right, by doing something called defining the function. Okay, if you remember with Carol, we would go down to the bottom and we would create a function. We would say function and then give it the name, then open parentheses, close parentheses, curly bracket, all right, and then we would list the steps of that function, right? So if we were doing the function turn left, we would say function turn left, parentheses, curly bracket, and then we'd have our command turn right, turn right, turn right, and then close it out, right? Well, then every time we wanted Carol to turn left going forward, we would call that function, all right? Then we could just say turn left in our program, and Carol would turn right 3 times, okay? So a function is really it's just a chunk of code that's got a name that simplifies the process. So if there's going to be steps in your program, different lines of code that are going to repeat over and over again, and say it's like 10 lines of code that you're going to repeat over and over again, rather than having to redo those 10 lines every single time, you can put them in order once inside a function, give it a name, and then every time you need that bit of program to run, that bit of code to run, you just call the function. Okay, so we can do this with direct lines of code. We can do it with conditionals. We can do it with combinations. We can do it with text. So this lesson, we're going to get into enhancing our gameplay by using functions. All right. So there's a video. I'm gonna skip over the video for the time being, but we will get to it. I would recommend after I go over this today, go back and watch the video, um, but because it is helpful. But we're gonna sort of jump right in for time's sake. Okay. So video is good. We're just gonna move on again since I'm doing a recording. I don't want to record a video within a recording. It probably wouldn't work well. Um, so let's just look at what we have here. So we're in lesson 24, bubble 3. All right. And we're calling functions. Okay. So it says functions let you build your own blocks and decide what goes inside them or what code goes inside them. So this program has already created 2 functions, but only one of them is being called. All right. So let's just look at what's going on here. We have a function called draw sky. All right. And all of this code, all right, is inside this function now. So we're saying we want no stroke. All right, we're given a particular color using the RGB triplet. So that's no red, a little bit of blue, a little bit of green, or sorry, a little bit of green, a lot of blue. And then we're filling with yellow and an ellipse. So what that's telling me, there's going to be a blue background and probably like a sun. Okay. We have another function called draw balloons. All right, we've got a lot of information there. So we've got all right all of this code, but this is just the creation of the function. This is just the function definition. So this is defining the function draw balloons. This is defining the function draw sky. This is calling the function draw sky. Okay, and to look at how that's going to work, if we go to our toolbox and go to the functions menu, if you notice, you've got 2 options. You've got one that sort of looks like you need to put stuff inside of it, right? So this one that has the word function and then my function. All right, what that means, that is defining a function. So you will use this block of code that's highlighted to create a function, define it, give it the ingredients, give it the steps you want it to have, but then to actually make it run in your program, you use this block to call it. So right now when we click run, the sky is drawn, okay? So we've created this function and this is making all of this happen. So if we want to have the draw balloons happen, we're going to call it. So we're going to drag this line of code out, and we're going to call draw balloons. Okay. And now when we reset and run, all right, we've got both elements involved. Okay, so the point of this is explaining to create a function. That's where you put all the steps, all of whatever you want to have happen. But to actually make that function run, you need to call it within your program. Okay, and notice here we don't even have a draw loop. We'll eventually get the function. The draw loop itself is a function. It's a special function, but right now we're drawing stuff without the draw loop. All right, reordering code. All right, so placing code inside functions makes it easy to read and make changes to. Good names for functions indicate what your program is doing to a reader. You can call your functions in a different order to quickly make significant changes to how your program runs. All right, so this program has already created 4 functions that draw parts of a scene. Unfortunately, it's not coming out right. All right, read the 4 functions to know what they do. Call the functions in an order that draws the scene the way it looks best to you. So let's run it and see what happens. So right now nothing's happening, so that tells me nothing's been called. So we've got a function called draw background, draw trees, draw clouds, draw fence. All right. So if we remember the concept that whatever is called first goes in the kind of the bottom layer, what probably needs to be the first thing we call so that it's in the back? Probably the background. So I'm going to call draw background, and then I'm going to reset and run. Okay, that at least gives me a background. Okay. Next, I'm going to call draw clouds. And then I'm going to go ahead and call draw trees. And then I think there's one called draw fence. Okay. And I've not done this one before, but that's just in my head. I feel like that might be the order it needs to go. So I'm going to run it. All right. So I've got a scene now where I've got my background. All right, I've got a fence. I've got trees. I've got clouds. Okay. Just as an example, if I went in the order the functions were created, I would have had the trees, then the clouds and the fence. All right. Well, that has a cloud in front of the trees, not as realistic looking. Okay. So once you call your function, you can reorder them and layer them. Okay. If I had my fence, all right, before the trees, it's going to give me the issue. The trees are going to be in front of the fence. Okay. So none of that's a bad thing, but again, you can play around with it. The order I think is best is to how we had it at first: background, clouds, trees, fence. All right. So again, define the function, then call the function. Okay. All right. So question, it says, does it matter where you create functions? All right. So far, all of your functions have been created at the bottom of your code. What do you think will happen if you call a function before it's defined? All right, notice that the red square is drawn before it's a function is created, while the green square is drawn after the function is created. Which do you think will be drawn? So we've got draw red. All right, there's a function defined called draw red. Then there's a function defined called draw green, and then we're calling it. Okay. So how many of you think the red square will be drawn, but the green one will not? Anybody have any opinion on this at all? I know it's Friday. I see some heads down, but I think they're both going to show up. One's going to show up. Neither. All right. What do you think? All right. Let's go with C. Okay. All right. And there we go. Okay. So what this is proving is it's good practice. I like to have my functions defined at the bottom of the code and then call them up top because then you can just follow the sequence of how the program is running, and then you can it's almost like with a book. If you have a book or like a article where you have sub notes, or that's kind of what the function definition is. It's important to have it there in the right context, but what is actually making it happen is the calling of the function. So, or footnotes is the word I was looking for. So I almost treat my function definitions as footnotes. They're at the bottom there for reference, but what's actually making it happen is calling the function, and that's the order I want to pay attention to. So, big scheme of things, it doesn't matter where you define a function. You can define it at the top, at the bottom. When you call a function, it's going to run as long as it's defined within the program. But it's good practice to define the functions at the bottom. Alrighty, so we've got a good bit of practice with functions. So you're going to look at this first one and see what's going on, okay? So it looks like we're going to now combine uh, functions with our draw loop. So it's going to be a function within a function. All right, so you can call a function inside the draw loop just as you would anywhere else. A function that will draw a background has been created for you. A sprite has been created to move across the background. All right, so call the function inside the draw loop so that the sprite appears on top of the background. All right, so we need to call the function. All right, remember, if we want the sprite on top, it needs to come after. So we're going to call trees background. All right, and then draw sprites. Okay, and now that draws our background with the trees, and the flybot is flying across. Okay, um, some of y'all are a very polite group, so nobody's going to say it. Some of you are probably thinking, "What in the world is the purpose of creating this draw trees, this trees function? I'm only drawing the trees once. Couldn't I just put all this inside the draw loop?" Yes, you could, but if you think about, if this tree's background works as it's intended, this is a lot neater. All right, because when you're working with interactivity and your scene or your game, it's a lot easier when the function works as intended. When you are dealing with fixing bugs, it's a lot easier to say, okay, trees background, that's where it is. I know that's how it needs to be. It makes it a lot neater, a lot more visually appeasing. When you have bugs, it's easier to sort it out when you use functions in this way. All right. Also, a note: don't create functions inside the draw loop. All right. Make them at the bottom of your code. The whole purpose of using functions in the draw loop is to simplify the draw loop itself. So we're trying to get all the clutter out of the draw loop. All right. Calling multiple functions. All right, so you often want to use the same code at many places in your program. Once you've created a function, you can call it as many times as you like. All right, this code creates a sprite that moves across the screen once. How can you make it go back across the screen? Note the function is already called once at the beginning of your program. All right, so we have set flyer is a function, all right, that sets the flyer with an x location of 450, a y location of 200, and an x velocity of -1. All right. So it's already created and it's there to start with. All right, read the condition of the if statement inside the draw loop. Why do you think it's there? So we have our trees background, and then we have if flyer.x is less than 50. All right, so the purpose of that has got to be relevant, and we know we've got the set flyer function. What I'm thinking, okay, is if the flyer goes off screen, all right, we want to account for that. So we want a condition that if the flyer goes off screen, we want to have something happen. So what we can do is then call set flyer. And this is now saying that if the flyer goes off screen, all right, this is what we want to happen. So let's reset and run. All right, I'm going to increase the velocity so we don't have to watch that for 20 minutes. So let's make that a 5 reset. All right, so the flyer moves, goes off screen, and comes back. Okay, so it's that sort of that looping feature that looping action there. Okay, so now what we have, we've got a function inside a function. All right, and then we've got a function inside a if statement. So you can use functions within conditionals. Conditionals can be part of functions. All right, so it's all sort of interchangeable in a roundabout way. All right, making changes to functions. All right, so a nice benefit of using functions to remove repeated code is you can now easily make changes to multiple pieces in your code. Just change how you create the functions, and your program will now use the new code everywhere your function is called. That is a major plus to using functions. Okay, so if we were not using this set flyer function, we would basically have this, outside of the draw loop, an initial setting of 450, 200. When we created the sprite, we'd have an initial velocity that was there. All right. Then we would want to update that in the if statement. So now if we decided we wanted it to start in a different spot, we'd have to update it two places without the function. With the function, we want the flyer to start at a random y location between 0 and 400. Well, now we can just update it here, or in the function definition. And now at the beginning of our program, it's updated, and inside our draw loop, it's updated. So that's the convenience of functions. When you have something run multiple times, you update it in the definition, and then everywhere else it'll be updated as well. All right, so now the flyer is coming across at different Y locations each time it's reset. All right, last practice, creating functions to organize code. All right, in Game Lab, all the action is happening in the draw loop, but too much complex code makes it really confusing to read. To keep your draw loop easy to read, use functions for larger chunks of code. You can call them inside the draw loop and define them below. This is a really good example of using abstraction to think about problems at a high level and worry about the details later. All right, this program should draw a daytime scene or a nighttime scene, depending on the location of the mouse. All right, the draw loop describes what needs to happen, but one of the functions hasn't been written yet. All right, so we want to create the draw night function, which has been created but it's empty. All right, it says look at the picture to the right for your night, what your night image should look like. Or you can use the draw day function to help you, or can you use it? So when we run it, all right, it's daytime. All right, we've got the sun, looks like it's over the ocean, got some twinkling water there. All right, and it stops when we get to a certain point. Okay, well, if we look, our world mouse y is inside an if statement. It says if our y is greater than 200, draw the night scene, else draw day. So what that means is if our mouse is above 200, it's going to be day. If it's below 200, it's going to be night. All right. So when we're looking at the example here, what we can do is work smarter, not harder. Okay, because my day scene has a sky, it's got water, it's got a sun, and it's got a reflection. I need all of those elements, but for night, I probably want my sky a different color. Rather than sun, I probably want the moon, right? And I may want my water a different shade. However, I can copy all of this if the program would let me. Okay. All right, let's reset. Maybe that's probably okay. And I can paste it inside draw night. It's like code.org might be about to freeze on me. Let's see. Let's try that one more time. There we go. Okay. So What they're using are RGB triplets. That's a little bit. I mean, you can use it. So basically, again, the first number is the amount of red. 0 is no red. 255 is all the red. All right, blue or green, and then blue. I'm gonna get rid of that, and I'm just gonna type in quotation marks dark blue, and I'm gonna see if that works. Okay, so that does work. Okay, so that gives my sky a darker color. All right, for the water, I also want it to change a little bit. So notice it's darker. I'm gonna try, and what I could do. Oops, let me go back to that. All right, let me make that like a 240. All right, so that's all blue. All right, that makes it brighter. Okay, so I want it darker. So instead of fumbling around with the red, green, blue triplet, I'm gonna see if maybe I'm gonna try and see what navy, if that's a color. All right, so that's the same. I want dark navy, so I'm gonna try some different colors. Um, if maybe midnight blue. All right, and that seems to give me a little bit of contrast. Okay, I could even go back to my dark blue and call that navy. All right, and that seems to be working. That's I know we have some folks with some color issues, but I'm typing those in. There is a slight difference. I could, and another thing we could do is we could also do a quick um, Google search and do RGB color picker, and we could find a shade that we really like. So if we like this really really dark blue, um, this is giving it to us in hexadecimal. We really want it. So RGB, it's 21166. So we can use this tool, and we could go back in 21166. We want to use that for our water. I could go back and add a. I could do 21166, and then that makes it darker. Okay, so using the internet as a resource, instead of having to fumble around and guess, we can Google RGB color picker. All right, find the color you want, and then they'll give it to you in the RGB numbers. Okay, so I've got the sky. All right, is about the right color. My water's darker, like I need it to be. Um, I need my sparkles, the little reflection. All right, I want it to be the color of the moon. So again, instead of the sun, all right, I want to use the moon. So I'm going to drag that out. I'm just going to use gray as a pretty simple color. All right, so that gives me a gray. And then my reflection, all right, is doing ellipses with a random number. And my fill is still gray. So that changed these as well. So essentially, I'm finished now. Okay, so what we're able to do is have two scenes that are called. So in our draw loop, this makes it a lot simpler, right? We can say, okay, if the mouse is greater than 200, draw night, else draw day. That's a lot easier to follow than if we had to have all of this code under the if it was greater than and then all of the code for the other scene right there. So again, the purpose of this is to clean up our draw function to abstract away all the unnecessary details so that now we just worry about, okay, draw night. I don't need to have all the details in here for drawing night. I just know it's going to draw night. Okay. All right. So that finishes our practice. All right. I'm going to leave this up to you to answer. So it says, what are three ways functions can be useful when you're writing programs? one answer, you can think of them on your own. One might be it allows you to save time eventually if it's code you're going to have to repeat over and over again. A function can help with that. Functions can help kind of clean up the program, so make it less congested, giving you names. Then also, with updates, like if you need to update some code that repeats itself and you have it in a function, you can just edit it in the function definition instead of having to change it everywhere where that code was repeated. There are other ways too, but those are three examples. All right. So step 8, we want to write our own function. So it says it's time to practice writing functions of your own. This is a very simple game in which coins fall from the sky and the bunny tries to catch them. All you need to do is write the function that sets up the coin. All right, read and run the code that already exists to make sure you know how it works. So we're running the program. There's a bunny that I can move left and right. I see a coin at the top that's stationary, and then there's a score. All right, so what I'm going to assume is that I need this coin to drop. I need the bunny to try to catch the coin, and if the bunny catches the coin, I want my score to increase. That would be my guess. Okay, so it says write the code for set coin, which is already set up down here. So that's going to set the coin's velocity to move down. So I'm going to do a velocity y for coin, and we want it to go down. So let's give it a positive velocity. Let's do 5. Okay. Set the coin's y position to the top of the screen. All right, so we'll say coin.y. Let's give it a 0 for now, and randomize the coin's x position. So we're gonna coin x is going to be a random x position between 0 and 400. All right, so let's finish, or let's reset and run. Okay, so now the coin, all right, is falling at random positions. All right, and what's making it do that is we have an initial function that's setting the coin outside of the draw loop so that it's at least set to start with. Then inside our draw loop, we have a conditional that says if the coin's y location is greater than 400, set the coin again. Okay. All right, so we're able to use that twice, and we're actually going to probably use it a third time here in a moment. All right, so we're continuing with this. So let's make the score change too and finish the game. So we'll need to be able to tell when the bunny is touching the coin and then reset it. So we want to use an if statement, and we can put this inside the draw loop. And we're going to say if, we're going to use our is touching. So bunny is touching coin. And we want to increase the score. So I'm going to look and see. I don't have a function for increasing the score. I could do that, but since I don't, my score is a variable called score. So inside that if statement, I'm going to go ahead, and now this is showing us where the function is helpful. I want to reset the coin. All right, so if the bunny's touching it, set coin. So now instead of having to update all that stuff, I just call that function. All right, and then I want to update the score. So I'm going to drag it x equals, and score is going to get the value of score plus 1. So whatever the score was before it touched, we're going to add 1 to it. All right. So let's test that out to make sure that's going to work. All right, so now our bunny touches the coin. All right, it resets. I couldn't quite get there. All right, missed that one. All right, so the last thing it says is play the game and randomize the velocity of the coin to a range you think is fun. So what we can do is with our coin velocity, we can give that a random number, and we can give it a random number. We could just say 0 to 10. So now the coin is going to fall at different speeds. Okay. We may decide that's too slow, so we may decide we want to make it get 5 to 15. All right, and then that makes it a little bit tougher to always be able to get to it. All right, but notice when we do touch it, our score is going up each time. So we've got all the elements there we needed. All right, change the background with a score. Okay, so once you've caught 10 coins, it's time to celebrate. You should change the background to something fun. So we want to do another if statement and separate two separate functions to draw your backgrounds. Okay, then go to your functions outside your draw loop. Okay, so what we're going to do, we're just going to put an if statement inside our draw loop. And we probably need an if else, actually. So we're going to say if, and we're going to use, that's aggravating. Okay. So we're just going to type it in since it don't give us a less than. We're going to say if, or we could still do this. So we'll say if the score is less than, we'll just use 5 to test it out. So if score is less than 5, and we can just call this background 1, else background 2. All right, now we need to create background 1 and background 2, but what this is saying is while if the score is less than 5, background 1 is going to show up, else background 2, meaning that if the score becomes, 5 or greater, the background's going to change. So now we'll create two functions. One is going to be background 1, the other background 2. Okay. And to simplify it for now, I'm just going to use a background color, and we can make background 1 yellow and background 2 red. All right, we're going to run it. So our background's yellow 2. We're going to try to get 5 coins, 4, 5, and now it changes to red. Okay. So that's a simple way of doing it with colors. I could decide that I want to possibly, we could look at using sprites for backgrounds. So instead of that, I could, within the function, I don't want to get too squirrely here, but we could call this, I'm just going to say BG1, and we're going to set an animation, BG1. All right, I can go to my animations tab, and there's backgrounds. So I could use, let's say I'm going to use farmland, and I'm going to use meadow. Okay. And for background 1, all right, let's test that out. Okay, so the order is going to be an issue. So this if statement of setting the background. I'm drawing sprites over my score. So that's where the drawing sprites is going to come into play. So I probably want to put this. So if I wanted to get that fancy, I'd need to create my sprites, set my animations there. So that's probably not going to work. I didn't think that one through. So I'm going to do this. Create these in the top. Before the others. And then we can just hopefully do a visibility. Okay, so now we kind of fix that. So we just need to go back to our functions. And what we can do is in background one, we can make BG1 visible true, BG2 visible false, and then reverse it. Okay. All right, now, okay, so now we do have the farmland. You can score. All right, it's working. Score 5, and then it changes. Okay, so sorry about that. Kind of fumbled through that one, but that's background sprites they're cool, but they kind of add that extra level of complexity. But that allows you to sort of change scenes, so to speak. So that's something when you are creating your own game, you may decide to use sprite background. So something I forgot to you need to create them outside of the draw loop and use your visibility settings within functions and possibly if statements. Alrighty, so the last challenge, I know there's not much time left. Some of you maybe started on it already, but we want to try to finish this challenge. So the provided code draws one of two different scenes based on where the mouse is on the screen. It either calls draw scene 1 or draw scene 2. So what you're going to have to do, all right, and we probably won't finish this today, but you're going to need to define draw scene 1 and then define draw scene 2. All right, so just to test it out and kind of show you the way you could go about doing this, um, let's just say, and you can make it whatever you want it to be. It can be two completely different scenes, but just to get yourself started, I'll just to make sure they're working. Again, I'm going to use a black and let's use a green. All right, and to run it, okay, I didn't capitalize scene, so it's gonna make syntax errors myself. Okay, so now, so it's set up so that if my mouse Y is above 200, it's going to draw uh, scene 2 and scene. So now what I can do is just add the different elements to each scene and then just reset and run and then move your mouse so you can see one scene or the other. Okay. Alrighty. So we'll give you some time on Monday. There's only about 5 minutes left or so, but we'll finish this up on Monday and then move on to lesson 25.